Hey guys, today we're going to be talking about scientific notation. Have you ever seen a number like that and just thought, what the heck even is it? Well, you're not alone. Scientific notation can look kind of weird and confusing if you're not used to it. But in all reality, all this number is a pretty large, regular, normal number. What we're going to do in this video is convert between scientific notation and a regular whole number, and we're going to go between a regular number and scientific notation. Now I say whole number, but it could be a decimal in some cases. I know, technically not the right terminology. But let's see what we do here. Let's first start with a nice whole number, and then we are going to convert back. So let's say we have 4,200,000. That's our number. 4,200,000. Big number, right? An awful lot to write down. Maybe you don't want to write that and all those decimals, not decimals, but all those zeros, that kind of stuff. So here's what you could do. Scientific notation says that all we really care about is the actual numbers. We don't care about the zeros. We care about that 4 and the 2. So here's what we're going to do. We are going to rewrite the number as just the non-zero parts. And when I say the non-zero parts, I'm referring to the beginning parts. Even if this was 4,200,001, to be honest, we kind of just round it and we only really care about this opening. But for the purposes of this video, we're going to be dealing with numbers that don't have that many non-zero digits. But we want to rewrite it as just the non-zero parts. Now, not only that, we want to write it where it is a single ones digit and decimals. So here's what I mean by that. Our goal to rewrite a large number like this is to take the very first number, and that's going to be our ones place. So in this case, 4. And after that, we're going to have a decimal. Any other number after this 4, any other non-zero number, gets written down after this. So in this case, 4.2. That's all of the actual number we're going to see in our scientific notation. The rest of this, all the zero numbers at the end, those are what we write with this part that we call times 10 to some power. Now the question is, how do we figure out what that number is? What is that exponent that goes with the 10? Well, where's the decimal currently at in this number? Yeah, the decimal technically is right there. It would be 0.0 whatever. We count how many times we would have to move the decimal to get it into this position, and then that becomes our exponent. So we count 1, 2, 3, 4, 5, 6. We would have to move that decimal 6 times to get it between this 4 and the 2. So we write 10 to the 6th power. Now here's the thing to remember. If you have a really big number and you're writing it in scientific notation, your exponent is always going to be positive. If you have a really tiny number, meaning 0.000052, something like that, then that exponent is actually negative. We're going to do some examples like that too, but I'm going to write that down here. Big number is a positive exponent, and and then a small number is a negative exponent. I know I misspelled positive, my bad. There we go. So let's do some actual examples about this. Let's get all this writing and stuff out of the way. Let's do some examples. And we're going to start with some big numbers. So let's do 324,000. Plain and simple, 324,000. So what we want to do is we want to take our very first number. That's going to be our ones digit. We always just start with a ones digit. We're never going to have like 10 or 15 or 25 before the decimal. Just one number. So 3 point, and then we want all of our actual numbers. These are also sometimes referred to as significant digits or significant figures. So 3.24 is what I'm going to write. Now we take a look at where the decimal currently is in this. Well, that decimal's currently after the last number, right? And we ask how many times would we have to move it to get it between the 3 and the 2? How many times would I have to move to get right there? Well, 1, 2, 3, 4, 5 times. So to denote that, we say times 10, and since this is a big number, to the 5th. Since it's 5 times, positive 5th. This is the same thing as that. Let's say we wanted to do 701 million. Let's say that. Yeah, there we go. 701 million. We want to write it in scientific notation. So we take a look at that first number. That is going to be our single digit, so 7 point. Now I know we said we ignore the zeros. This is the one kind of area where we don't always. Since there's an important number after this next zero, since that one we care about, since it's an actual non-zero number, we still want to write it, but we have to take into consideration there's that zero first. So we say 7.01. The deal is that we include the zeros up to the last actual number, the last whole number. We include the zeros up to that. But the rest of the zeros, after we hit 0, 0, 0, 0, however long it goes, those are what we turn into the scientific notation. But this is still where we put our decimal after the 7. So we look at where our decimal is now. We count how many plate times would it have to move to get right after that 7. 1, 2, 3, 4, 5, 6, 7, and 8. So 10, and since it's a large number, to the 8th power. We did it. Let's try out one, what I like to call small number, before we talk about converting back. And let's say we have the number 0.00036. We follow the same kind of idea. We ignore all these line of zeros until we see an actual number, meaning that 3 and that 6 there. We take the first number we see, the first number we run into, in this case the 3, and that becomes our single first digit. And our decimal is going to take place after it. So after that 3, we care about the 6. And then to figure out our exponent, our times 10 to what, we see, well, if we want to move the decimal right here after the 3, how many times does this decimal place need to move? Well, 1, 2, 3, 4 times. But here's the really important part. Is this a big number or a small number? It's really small, right? It's 0 point something. That's like the tiniest number. And whenever you have small numbers, otherwise numbers that are less than 1, you have negative exponents. So we moved it 4 times. but since it is a really, really small number, it's 10 to the negative fourth. Another way that you can think about this is that if you had to move the decimal left, then it's a positive exponent. If you had to move the decimal right, then it is a negative exponent. All right, let's finish up this video starting with a scientific notation and writing it in regular form. Let's say we have 9.15 times 10 to the negative sixth. So here's what I'm going to do. I'm going to take these numbers and I'm going to write them without the decimal, but I'm going to remember where that decimal was. That decimal was after the 9, right? And I have 10 to the negative sixth. Negative means it's going to be a really small number. So I need to move that decimal way in front of it and make it look super, super small. So I'm going to remember where that decimal started after the 9, and I'm going to move it 6 places. So 1, 0. Sorry, I actually miswrote that. 1, it would move in front of the 9. 2, it would move in front of a 0. 3, 4, 5, 6. We now move that decimal 6 places, right? 1, 2, 3, 4, 5, 6. And we did it. We wrote our number. Since it's a negative exponent, it's a really tiny number. If we had something like 5.78 times 10 to the third, then we would do this same thing. 578, I'm going to write it without the decimal, but again, remembering where that decimal was, and I'm going to move it 3 times. Now, since it's a positive exponent, it is going to be a big number. So I need to move that decimal so that it makes it look like this number is a little bit bigger. I'm going to move it this way. So if it started here, then once, twice, 3 times, right? I have to add 1 0 there, and then the decimal would be right here. 1, 2, 3 spots away. So my actual number, 5.78 times 10 to the third, is 5,780. I know scientific notation can be a little confusing, but once you get the hang of it, it'll become second nature for you. I'm not saying it'll ever be second nature to write numbers in scientific notation, but you'll pretty easily be able to convert back and forth between them. If you have any questions about this, drop them in the comments below, and I'll be more than happy to help out however I can. Thanks for watching, guys, and I'll see you next time.